So I'm Stephen Fletcher with ginstudios.com, and I'm here to talk about dependency injection. If you want to go to our website, it's ginstudios.com. First, I want to go ahead and talk about uxok.org. UXOK is an event that's coming up on February 5th, and it's going to be hosted by Techlahoma, and it's going to be sponsored by Gin Studios. At least the lunch portion is sponsored by Gin Studios. So if you want the free lunch being delivered to you, and there's enough tickets remaining for the full swag and lunch ticket. I know that they're running short, so jump on those. Or just do a no swag ticket and come on and join the UXOK. I'm very much middle guy, even though I claim full stack. But once it gets to the very front end, and then there's like the user experience, stuff like that, I'm a little bit disconnected. So I'm really interested in UX stuff, just to sort of get a glance at the people talking. There's some really big names talking, and these people are they're like brain leaders, brain traffic. Christina Halverson, she's huge in UX. So it's a great thing. It's a great talk to go to. So I want to put that out there for people to visit that. So what I'm going to be doing a talk over today is dependency injection, pure dependency injection. So if you wanted to follow along or download this code that I'm going to be going over, it's github.com gin-studios/di. And you can either follow along or later on go and look at the code that I'm going to be reviewing here in a little bit. So let's go ahead and jump into it. The scenario I'm going to be going along with here for dependency injection is going to be a shopping cart. So there's no UI involved in my talk, but the idea is when somebody goes to a shopping cart, they're adding products to the shopping cart, and then they go to the shopping cart page and it says the total. Like, this is your total, it calculated tax, it calculated shipping, all that sort of stuff. And then once it has calculated that all and you agree, this is okay, this is fine, this is what I want, then you hit checkout, you put your payment information in, and the order is then officially shipped to you or whatever. That's sort of the progression. So starting out pretty simple here with a console application. I'm going to first talk about no DI. Like, this is no dependency injection. This is just super basic pseudocode in a way. So we have an order service. We're going to create an order service. We're going to assign a new instance of an order service. And also, this is very C#. Everything I'm doing is C#, but hopefully you can find a lot of parallels to Angular and front-end TypeScript type things. I know I use dependency injection in every language that I do. So if you're here and you're not specifically a C# master, then hopefully you can apply these to your other things also. So we've created this service. What we're going to first do is say calculate order. So I'm going to put in my customer ID, and of course this would usually be passed into an API or something dynamically, but I'm just going to hard code a customer ID here, and the list of items that I want to calculate. So the list of items is empty, so when you calculate the cost for that, it's going to come back 0, but I'm not demonstrating actual all that sort of stuff. I'm just trying to stick with focusing on dependency injection. So calculate order for customer 1, all of these no items, and then when I get that order result back, then I'm going to say, okay, let's go ahead and create that order with payment information. And of course, there's no actual payment information in here because I'm just demoing this stuff. So if I run this, make sure that I'm right here. Make sure I hit that breakpoint to prove that I'm going through the right thing. Yeah. Okay, so I run this, and what I get back is order total $0, order created true. All right, so everything worked perfectly fine. I've got an order service, I've calculated the order, and I've went ahead and created the order with payment information, and I got back all the details. Everything's perfectly fine. So there's no dependency injection happening here, but I just wanted to show how basic a console application can be, and then I'm going to go ahead and walk through all of the real problems here that will be occurring inside of calculate order because there's no dependency injection. So if I go ahead and open up that, should be here. Okay, so the first thing that we're doing, I only have this up here to show that it does. This actually is based on an interface called iOrderService, which just has a calculate order and a create order in it. But we're not doing dependency injection for this example, so I just have it commented out. But calculate order is the very first thing that happens. I pass in the customer ID and the list of product IDs that I want to calculate for. The first thing that we're going to see here, which I know is super cringy if you're watching this and you know about dependency injection or configuration injection for that matter, I have a hard-coded connection string here. Obviously, that's not going to work for any type of continuous integration or continuous delivery. So this is, of course, really bad. But what I'm doing is I'm creating a customer repo. It's a repository for customer information. And then I'm creating a product repo to get the product information, so I can do these two things. I'm going to use that repo to get the customer by ID. So here now I have a customer model. And then I'm going to use the product repo to get all the products. So now I have the product information. And these are just assignments. I'm not doing any logic here yet. I may be doing logic inside of these other methods, but so far in here, I'm not doing any logic. I have, with that information, I can now say calculate order. So I'm going to pass in the customer's discounts that they have available to them, their address for the shipping information, their customer ID, some product information. I'm going to call calculate order. And then after the order is calculated, I'm going to then create the order in the database so that later on we can pull it as a cached order. And I'm not saying follow these rules when you create an order microservice or an order history or an order system. I'm just saying this is what I'm doing to demonstrate dependency injection. So let's go ahead and jump into calculate order. So I'm just assigning a new order model, but there is something that's logical here. I'm doing a sum, I'm doing an aggregate where I'm doing actual arithmetic in here, and I'm summing those things up. I'm getting the net total. So there is something more than just assignment happening in this method. And here I'm creating FedEx requests. This is another thing to point out, is that in this code, I have a direct dependency on FedEx. So that's something that we're going to want to fix later on. So I've got FedEx requests. I'm creating from a list of products. I'm creating a whole bunch of requests to FedEx to see how much each of those products cost to ship. So I've got the weight, the height, the length of the package, the width, the declared value, and all kinds of other information in here. And then I'm going to say, with all of these different requests, I'm going to do another aggregate. And for each one of those, I'm going to call the FedEx service, and I'm going to calculate the shipping fees for those requests. And it will sum those up and put those in the total shipping. So now the shipping of that order will say the total shipping of all of the requests for all of the products. So there's a lot of logical stuff happening here, some third-party stuff, some sums, and I'm going to get into why I keep pointing out the difference between assignments and logic later on. So I've calculated the order. I've returned back to the user interface. This order is going to cost this much tax, this much shipping, all that sort of stuff. And they're going to say, check out, put my payment information in. We're going to go to, we will then call create order. So we've got their payment information. We've got the order ID of that order that we created and showed to them previously. So we're going to look up that order. We're going to pull that back in with a new order repo. And we're going to process the payment. I'm not going to get into all the logic of payment processing or anything like that, but we're going to process the payment, pass in that information, the total that we want to charge. These are just assignments. Let me touch on what this is right here at the end of this description. So I'm going to update the order status, and this is just an assignment here. I'm going to create a customer repo, and I'm going to get the customer info, and now I have the customer address. So I'm going to use FedEx again. I'm once again tied to FedEx. So I've got the FedEx shipping request with all the information of what I'm going to be shipping. And I have this thing right here. Since we're using FedEx and we create a new shipment, when we do that, FedEx sends back a GUID. So this method right here sends back a GUID for their tracking number. And so we've created in our product model, the shipping information for that product is going to be a tracking number with a GUID. So that's another way that we're now tied to FedEx. And I'll get into what we're going to do with that later on. Update the order status to shipped, and we're good. We'll return to the customer. You've given us your payment information. We've shipped everything. Everything's all set, and you're all good. Your order's been placed, all that sort of stuff. And this code works. If you were to publish this with all the appropriate stuff, the code works. I showed whenever I ran it that we got back information and everything seemed to work perfectly fine. But there's so much wrong with this where we're tied to FedEx, and all of the code is sort of just spaghetti code and pushed into here, that I want to I want to show you guys how to decouple yourself from all of the things that you're not concerned about. You can see that this is 94 lines of code inside of the order service. A lot of it doesn't belong in here. Process payment doesn't belong in here. The stuff related to FedEx really shouldn't belong in here. So I'm going to show the order domain, no DI, CI only, order service. What I'm going to address first is for CI/CD, I'm going to take those connection strings and I'm going to require somebody to pass them into me, whoever's consuming this order service. So in this case, it's a console application. The console application, now when it creates an order service, has to tell me what my connection string is and what my FedEx license is. And all of this code is exactly the same. I'm just doing all these assignments here. And instead of those connection strings being hard-coded, I'm now requiring you to give me those connection strings. This is not exactly dependency injection. This is configuration injection. Yes, I depend on these, but it's not what we usually think of when we think of dependency injection. But it's following the same pattern where we are saying, I'm an order service. There's things that I need that I shouldn't be concerned with. I shouldn't care what the connection string is. I do need one. You tell me what it is whenever you're ready, because you may change that. But I don't need to know what it is exactly. You just let me know. Every time that you create an instance of this, let me know what it is. Okay, so I'm going to go ahead and come back down here. All the code is the same as before, except that I'm using these injected values. But I'm going to touch back on this condition that I said I was going to touch on before. There's a lot of different versions of testing. There's integration testing, system testing, regression testing, and all the different types of testing. As a developer here in the domain, the testing that I'm concerned about is unit testing. Now an SDET, a software development in charge of testing, they're really concerned with Selenium tests and using Postman, making tests in Postman and system tests and all that sort of stuff. But as the backend developer, I'm really interested in unit testing. So I'm going to assert to you that this method is not testable as far as unit tests go. At least there's no value in tests. All I'm doing is assignments and a for each. For eaches, depending on what you're doing in them, are typically testable. In this case, I have a dependency on a third party, and that's going to get mocked out, and I'm not going to go into that right now. But this is something that I'm going to tell you is not testable. Let me show you why. So if I said if payment status, if I just had this, I think it's more clear that it's not testable, because what are you testing? I mean, yes, there's a conditional, and having a conditional is one side of being testable or worthy of testing, but nothing's happening. So what's the point of trying to test this? It doesn't really make sense. And then I also have something, let's say I had order.net total equals 10. This is a transformation, and you might think, oh, transformations, we should unit test that. But there's no value in testing this, because your unit test will literally also just say plus equals 10 in your unit test from whatever you pass in to what your expected value is. And so if this ever changes, someone has a requirement change to 15, you go change the unit test to 15. And there's no value in this because it's not variable. There's no conditional or variable usage of this change right here. So not worth unit testing. Similarly, even though this condition will change the result of this create order, the real thing that we're testing against here is something that's happening in process payment. The value of this condition is actually the value of process payment. So whatever the value of process payment is, which has its own unit tests, there's no value in me trying to retest process payment, which already has full-on unit tests here. So what we call this is a guard clause. And a guard clause is not unit testable. This is sort of a side note, sort of a look in the future of some other talks I might be doing. This is not unit testable. Assignments are not unit test worthy, and guard clauses are not unit test worthy. That's a side note for later on. So we've got create order. We have the repositories. We're injecting these connection strings. Let me jump back over to the console and jump into what we expect to happen when we do dependency injection. All right, so here we have dependency injection happening. I feel like I'm getting ahead of myself. I'm going to jump back over to the consumer, to the order DI one more time, because I forgot to do this, the UPS. So assuming that the we already have connection strings handled, assuming that the connection string changes the password, we have it change monthly or whatever the case is for security, whatever we decide we want to do. The business then now comes back and says, hey, we've been working with FedEx, but they've changed all of their pricing, or they don't handle shipments of livestock or something like that. So we need to change everything to UPS. So we go into our existing class and we say we need to change this class so it uses UPS instead of FedEx. We're completely getting rid of FedEx. We're not going to ever use them again. We're going to use UPS. So we still have these problems here where we are instantiating repositories, even though at least we have the connection strings in here. But our real problem comes when we have to change all of this code right here. Actually, I think I can do this. Yeah, show the changes. That works. So we have to change all of this code. Instead of being FedEx shipping request, we're changing it to UPS, a UPS shipping request. Instead of a height, length, width, UPS requires that we give it a centimeters cubed. I just made that up. I don't know anything about their API. I've actually used FedEx a lot, but not UPS. So what we're doing is we're changing the logic here. We're having to multiply. And what's even worse, apart from this, and then similarly down here and in our dependencies and everything like that, the worst thing is UPS. Come up here. We were so tied to FedEx that it doesn't matter. I'm just trying to go show you. The shipping GUID is a GUID, but UPS gives us back a long. So they give us back a long instead of a GUID. And now not only do we have to change some of this logic here, we have to change our whole system. We have to go into the database, change the type of the field, we have to change the entities and the models, and it becomes a much bigger undertaking than it really should have been to begin with. Yeah. So that's another problem that we have. So we have to make all those changes, and we're going to go ahead and of course, I've already done a lot of that stuff. So okay, so we've gone through our whole system. We've changed our database. We've changed everything, and now we've got UPS requests working, and that's all fine and dandy. Except now they say, well, for some people we're going to do FedEx, and for some people we're going to do UPS if they need livestock shipped or we need something else. So we really don't know what we're going to be doing here. A lot of UPS, a lot of FedEx, but my main point is that we don't know which type of services we're going to need. A UPS service, a FedEx service. It's really not this class's job. The order service shouldn't be caring about the database. They shouldn't be caring about our third-party services. So we need to decouple ourselves from all of those things and say, I'm just in charge of orders. I just want to calculate some stuff and give you how much the total is and stuff like that. If I call out to a database, I don't want to know what it's doing. I don't want any part of it. And so we're going to get into the idea of compile time versus runtime. Yeah, sure. Okay, so whenever I am looking at this code, I'm a developer, I'm running an IDE, and I'm looking at this code, I can see that, go back here. I can see that I've got an order service. And I can see that an order service calls calculate order. And I can go into calculate order, and I can see that it calls customer repo. And if I were going to customer repo, I can see it calls entity framework. I can go to entity framework and look at the configurations it calls SQL Server. So when I'm looking at code, I have the entry point of my application. Could be an API, could be the main, could be whatever it is, an event handler. It calls this, it then calls this, it then calls this. So that's what it looks like. Now, when I run this application, if I were to step through the code, I actually don't know if I can step through this code. I think I have my symbols set up. Let me try to demonstrate this is correct. I can. So I can see that I have an order service. I've stepped into my order service. I can see my order service has a repo. And if I call customer ID, I call into the repo. And at runtime, I'm going from my entry point to the order service, to the repo, to entity framework, to the database. So I just said the same exact thing twice. At compile time, I can see the progression of what I'm going through. And then at runtime, I can see the progression of what I'm going through. What that means is that my control of my application whenever I'm in compile time is the same way that it's controlled when it's at runtime. What we want to change is that at compile time, I don't want to have the same exact progression. Instead, I'm going to inject something into the middle. I'm still in the consumers. I'm going to inject something in the middle called a core. And in this core, I'm going to have an order service. Or maybe not even in the core. I'm going to have a repository, a data core. And I'm going to have a customer repo, an interface for customer repo, an interface for my order repo. And I'm going to stick this core somewhere in between. And now what happens inside of my code, once I refactor on that stuff, now I say I'm going to start with my order service, and I'm going to go into, instead of customer repo, which this looks like it's customer repo because it says customer repo, I'm actually going to an interface. So I'm now going backwards. I'm going from my order service backwards into an interface. And then I stop. I'm not going forward into a repository. I have no idea a repository exists, that it's using Entity Framework, or that it's using SQL Server. I have reversed that and said, okay, I'm going to stop where I am. I'm going to look back into this core application, and I'm going to reverse my at compile time, reverse my direction back to this interface. And that's where things sort of get turned around. That's why they say inversion of control, is because I've come from going one direction from my entry point to the order service, and it looks back and says, hey, I'm going to go backwards here and look at this interface. But here in the consumers, when I go to the dependency injection, you can see that I've taken a dependency on an interface instead of a direct concrete instantiation. So I'm going to say, let me run this. So now I'm going to go into the runtime. At compile time, I've reversed things and I've looked back. Oh, I don't like that that's happening. So at compile time, I've said that I'm going to reverse thing. I'm going to look back at that interface. But at runtime, I'm going to say service.calculateOrder. I'm going to go from an order service. I'm going to get this service here. Let me just do this again. Oh, God. They say this happens. They say this happens when you talk. So this service, I'm going to say that when I want an iOrder service, that I want to be injected with an order service. And this order service is, so that's the next progression. And then from the order service, we're going to say calculate order, which is going to be on the order service. And calculate order is using an iOrder repo. But since my dependency injection is telling it for an iOrder repo, you use an order repo, it now knows about the repository. And for the order repo, it knows about Entity Framework. So runtime, since I'm injecting an actual concrete instantiation, not just an interface, at runtime, I'm using a concrete instantiation. So runtime still goes from my entry point to my my order service to the repository to the framework to the database. It continues to still go the same exact direction. But at compile time, I have inverted those dependencies, inverted the control of those, and said, when I get to my order service, I'm going to look back into an interface, and I don't care what happens from there. You can inject me with something. That's the reason why that's called inversion of control. So I will get past this and say, what I've done here is instead of just saying I need a connection string and I need a FedEx license, I've instead said I need the order repository, the product repository, the customer repository. These are things that I have dependencies on. I depend on them, but I don't want to know how they're implemented. I don't want to know about the actual code. I just want to follow a contract. You tell me that you can add an order, get an order by ID, update order status. You tell me you can do these things, and I don't care how it's implemented. One of the huge benefits of that, if I show you the project, this is the project for the one that does not have dependency injection. It depends on some core projects, but it also directly depends on the actual data implementation. It actually depends on UPS. It actually depends on FedEx. But if I show you the project for the dependency injection, it only has dependencies on core products. It doesn't depend on data access. It doesn't depend on third-party things at all. Nothing depends on anything. It only depends on stuff that I control. So I have dependencies only on interfaces, and I've cut my code down from 96 lines, which it was in the original one, down to 58. So let's go ahead and walk through how simple this is now. I'm saying get customer by ID still, just an assignment. Get products by ID, just an assignment. I'm saying calculate order. Now calculate order is very interesting all of a sudden, because calculate order takes in the product info, it takes in the discounts, it takes in the customer ID, but it also takes in a function. Let me show you the signature for this. So the products, the discounts, the customer ID, and a function that will take in an order model and return the decimal amount for calculate stuff. So the way that I use that is I create the order and I say shipping is calculate stuff. Previously, that was happening by, what was happening is it was creating all of the necessary request objects, and it was calling the necessary third-party application, and it was summing them up. But this isn't stuff that my order microservice should know about. It shouldn't care about FedEx. It shouldn't care about how it gets those shipping fees. Maybe they're calculated. Maybe it's a third-party SDK. Maybe it's in the database. It shouldn't care. So what I've done instead is I've made this function called calculate stuff. So I just call calculate stuff. This may be, like I said, calling an SDK, calling outside, but it may also be when I'm unit testing, if I were to call calculate order, I can pass in my own Lambda here that just takes some list of products and just sums the total. It doesn't make any third-party calls or whatever the case may be. It just calls calculate stuff. Let's go back here. All right, so calculate order now takes the product info, the discounts, the customer ID, and this function. So this function is passing in an order model, and it's calling shipping service, which is a third-party dependency that's outside of my code, .calculate stuff. Of course, in here, I could just return order model.products.sum. Link. I could just pass back this. So there's no third-party dependency. Whenever I do a unit test, this is probably something that I'd be doing exactly like this. But it just so happens that from this impure method, which has dependencies, I'm using my dependency here. And I'm telling it, use this dependency to calculate stuff. And this is impure, whereas this, it doesn't know it's impure, So as far as it's concerned, it's pure. There's no database calls. It doesn't know of anything that's happening. So we've used our dependency injection to have an impure call out to a database that is internally treated like it's pure. In a unit test, this makes it really, really easy because I can populate this method with something that's just like a regular sum. I don't need to be hitting a third-party thing at all. So we've got our dependency injection with the order repo. We've got our dependency injection with the customer repo, the shipping service. Now this code is super clean. It's so clean. I mean, we have an assignment. We have an assignment. We have a guard clause. We have an assignment, 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 assignment. There's nothing to it. There's nothing to this code. There's nothing to program. There's nothing to unit test here. There's nothing to unit test here. We have our dependency injection. And now, since we, instead of depending on FedEx, we depend on this thing called shipping service, which is I ship stuff, calculate stuff, create shipments. We can now inject whatever we want to this I ship stuff. So let me show you how I do that. Okay, so when somebody asks for I ship stuff, I'm going to return them a FedEx shipper. Right now, for this particular project, it's just hard-coded to a FedEx shipper because at the moment, we're using FedEx. So I'm saying I'll give them a FedEx shipper, which is something that I created. And in that FedEx shipper, I've put all the logic that FedEx needs in order to accomplish the tasks of I ship stuff. So we're fulfilling this calculate and create requirement using FedEx. But there's also I'm gonna get into the UPS stuff later. I could also say UPS shipper. UPS shipper. I could also say I want a UPS shipper, and then I'd have to fill that in with its own thing that it needs also. But all right, so I ship stuff is now what we depend on. So our domain logic doesn't even know that FedEx exists. It doesn't know that UPS exists. We will tell it whenever we decide which one we want it to use. And then once we switch out to UPS and we have all the UPS implemented, we can just come in here in this one place, change it over to the UPS shipper instead, and then the code should still work. So there's an idea here that when we switch out these dependencies, that your tests should break. And so I want to address that here. The reason why we would say that if you switch out these dependencies, your test should break is because somebody doing a system test in Postman or something like that, or Selenium, and they're going through the UI and they make an order and it creates a shipment. It'll then return the tracking number, and then your test case will then go to open up FedEx.com, put the tracking number in there, and everything should work. It should give you back your tracking information on FedEx.com, looking at tracking, all that sort of stuff. So your tests should definitely break. Your system tests, integration tests, all that sort of stuff should definitely break because you swapped out dependencies. The whole system has changed at that point. From my perspective as a unit tester, no tests should break. So as a unit tester, the FedEx shipper has its own tests, and that's isolated from me. The UPS shipper has its own tests. It's isolated from me. My whole order service is tested regardless of what it's using, like I was showing over here in the logic. It's just being passed in a calculate stuff. And so that's completely separate from FedEx or UPS. And so that should work just no matter who I'm using. So in my unit test, I'm not calling to UPS or FedEx. In my unit test, I'm just going to be passing in my own calculate stuff where I just sum up the total of the products or something like that. Or do a certain percent of the products we're shipping, or whatever it is that I end up wanting to do. So me going into the consumer and switching out if the consumer is using FedEx or UPS should not break tests from my perspective as a unit tester. So that's how dependency injection works in a pure way. I'm not done. I have plenty to say about API. I'm going to go into Web API here in a second. So this is what I would say is the purest of dependency injection. I have a program. It's a main program. I need a service that is an I order service, and I have what's called a composition route. In my composition route, I have composed my whole application. I know I have an iOrder service, which has dependencies on some repos, payment service, and an iShipStuff. I have an iShipStuff, which is a FedEx shipper. It has a dependence on the actual FedEx service. And so there's the FedEx service. I have an iOrder repo. It has a requirement of this configuration. This is pure, perfect dependency injection. Anytime that I need something, it'll call out to here. I give it an actual concrete instantiation of something, and it's perfect. I'm not using AutoFac or an injector or anything like that. This is the purest of the pure. So now I'm going to go into the API. Run the API. Okay. All right, so I've run this API, and this is the same thing that you would have seen on the other console when I was running the other console. Order total $0, order created true. And so I hit this API, and what happened, if you already know Web API or ASP.NET, you'll know that you should see possibly some configuration for some dependency injection in here. But what I'm doing is actually in my API order with no dependency injection, calculate with the customer ID. So I've got this API. I'm just doing the dependency injection right here. And this is actually okay. I called it no DI. I should have called it the latest DI, as late as you should possibly go. You can see it works perfectly fine. API, order no DI, calculate customer ID 3. What I'm doing here is I'm saying this is the only place in my entire code where I am using the order service. And so this is the place, this is the earliest possible place that I know where I can hit this and I have a requirement, I have a dependency on the order service. The reason why I say it that way is if I were to put a breakpoint here, or here, or here, and I say refresh, oh, there's already one there. Refresh. It doesn't hit those other breakpoints. This is the entry point of that call. Whenever I make a call there, this is the first thing that I'm hitting. And so this is a perfectly acceptable place to say, I'm going to do dependency injection. I'm not telling you to do this, because the moment that you need this order service again in another one of these methods, like for another call to get by ID or something like that, you're now having to duplicate these. So of course you don't want to do that. But this is still pure dependency injection. What I'm doing is I'm saying I need an order service, but it needs these things. So I need a product repo, but it needs a connection string. So I have a connection string. I need to call config.getValue for connection string, which I have that stuff inside here. However, since we're going to have multiple calls in this controller, surely at some point, what I'm going to do is I'm going to change it up to the constructor. So I've taken it out of the call. This it's not the responsibility of this call to do the dependency injection. It just needs the order service. So you see how much cleaner this call is now. The result is calculate order, and then I'm creating the order, and I'm outputting that same exact thing. But in this case, I'm doing all the dependency injection directly in the constructor here. So I don't want to get into this right now, but what I'm saying is I need an order service that's assigned to a private field on the controller. It needs some dependencies, so I'm creating the dependencies. It needs a connection string, so I'm getting connection string. This is still perfectly fine dependency injection. As a matter of fact, if this controller were the only place using this order service, and this is even prior to .NET Core and back in the day, you can do this perfectly fine because you're not hitting these other all of the hooks in the application. You're not hitting all those hooks constantly. So if this is all you needed, this would be perfectly acceptable dependency injection. However, moving it up one level is even better because we don't think that the controller should have to have the responsibility of knowing all these things. Even though it's perfectly fine, I'm going to move this up one level higher, and I'm going to say API register DI. I'm going to say here inside of your startup or your program for your application, what we're going to do is we're going to say in the configure services, and you'll know this when you do any sort of .NET, ASP.NET core development, at least 3.0 or later, we're going to say add transient, add transient, add transient, add transient. The difference between this and this is that this is actually registering dependencies instead of straight up instantiating them right here. There's no registration. It's going to instantiate these every single time. It's going to instantiate these every single time too. But this doesn't matter what order you put it in. So the order service actually requires an order repo, but I have this underneath it. So you would imagine that if it needs an order repo, it should be above it. But it's not actually instantiating these right now. It's just registering that, hey, if you ever happen to need one of these, you know where to find it. Just go look right here. It's registering all these things and putting them in memory. And so what you do is you say services, which is passed in to your configure services in this iService collection. You're saying add transient, which means every time that you need one, do this. So I'm adding a transient, and I'm saying if someone ever says I need a product repo, give them a new product repo with the connection string every single time. You might also see add singleton. I suggest against adding singleton. Transient has no overhead if you're doing your construction correctly. So a constructor, as we can see here, shouldn't be doing any logic. I mean, I'm assigning an order repo. I'm just assigning these things to variables. I'm assigning this to a private field. There's no logic. There's no calls to a database. There's no calls through an SDK. There should be no problem with any overhead in your constructor. So add transient should always be the best way to do it. Also, if you say add transient, then every time you call it, this connection string should be able to change. So while you're still in the middle of running your application's running, and somebody says we need to change the password of the database, they change that in, I mean, this won't work here inside of a web config, but if you're pulling your connection string through like Azure Key Vault or something like that, it should be able to dynamically update that connection string. And since you're doing this as transient, every time you ask for an iOrder repo, you're going to get back a new order repo with whatever that dynamic connection string is. But if you do this as add singleton, then on startup or as the application pool restarts, which is every 15 minutes or whatever the case is it's just going to cache whatever this value is. So if you happen to have the application start, it's running with one connection string, and then someone changes the password, for 15 minutes, your application's not going to work because it's using the old connection string stored as a singleton, and your application just won't work. So configuration injection is actually the main reason why I would say you don't want to use singletons. So this is the way that you register things in ASP.NET. You say, I have a dependency on an iOrder service, so give them an order service. The order service has these actual things in its constructor, these parameters it requires in the constructor. So I'm going to say get service for iOrder repo. So what's going to happen is it'll be recursive. It'll say, okay, let's go back through here, and we're going to find where they registered iOrder repo, and we're going to give them this. And so when they get to a ship stuff, they're going to say, we need this. I'm going to give them a new FedEx shipper, and it requires this. Okay, so let's find where they're registered for iFedEx service. Okay, there it is, and it's just recursive. It'll find all of your dependencies. It will it'll find the results. It'll resolve those dependencies, and everything should work. So we've gone from the constructor and instead said, let's use this Azure DI, run that. Output for fun. Should just skip it on that. Let's just refresh. Okay. All right. So same exact thing. Order total $0. Order created true. And so that's another way of doing it. So let's jump in one level deeper now and say autofac. So we're going to go from registering these transients right here in configure services, and we're now going to instead of in configure services, which is now empty, we're going to create a new thing called configure container. So configure container is another magical by convention method that occurs in ASP.NET. You use this method, it will pass you whatever container builder you have. This is an autofac container builder. And then you can do the same exact thing. So instead, for autofac, what I'm doing here, instead of add transient, what I'm saying is register iOrder service, and it's just the same exact thing. And an x.resolve instead of get service is get service. So I've pretty much just copy pasted the stuff from here, put it up here. It's the same exact thing, just a little bit of a change of terminology. In my opinion, I don't see the point of this. It's built into .NET Core, but if you want to do, if you're already used to using autofac, then you can do this. There's a little bit of something extra in case you're watching this and using this as your tutorial. You need to say use service provider factory up here inside of your host creation, and usually this is in program, and usually this is in startup, but I put it all here in program, the same thing. So use service provider factory is what you need to add, and you need to create a instantiate that with the autofac service provider factory. And that's what we'll tell it to say. We'll go in here, we'll pass you your factory, we'll pass you your builder, and then you can do the same exact things. I think that that's just extra work, and I don't see the point of doing this with autofac, but in case that's what you want to do, there you go. This, say run this, and there we go. The autofac DI, the same exact thing. It works perfectly fine. All right, so I've gone as deep as I can with dependency injection. The multitude of correct ways you can do it. Any one of those are better than not doing dependency injection. So now I'm going to go into one version that is called bad dependency injection. All right, APA bad BI. Let's do this, do this. All right, so bad dependency injection. We have pretty much the same thing. We've got an empty configure services. So we're using autofac, which means that we're using service provider factory for autofac. And it's passing us our container builder. This is all pretty much the same code, except a couple of differences. Instead of register, I'm using register type for the order service, and for the payment service, and for the UPS service. The reason I'm using service type is because these are just dependencies. If you remember, the order service has a dependency on a bunch of repositories and payment service and stuff like that, but it didn't directly have a dependency on like a string or a configuration. And the reason I'm using register here for iOrder repo is because it has a dependency on a configuration. So you're sort of forced in autofac to say use register, register an exact concrete type like this, so I can pass you in a configuration. The problem with this is the order service. If somebody were to say, I need to come in here, and we've decided instead of UPS, we've switched from FedEx previously to UPS. Instead of that, we want people to use FedEx or UPS sort of dynamically, depending on what they're shipping. So we're going to say in our order service, instead of using an iShip service, we're going to use a builder or a factory or whatever the case is. Don't use this code right here as production code, but the idea is instead of a ship service, we're gonna swap it out. We're going to use this iBuild ships, which means we no longer have a dependency on a ship service. We're using the ship builder instead, and instead of saying ship service, which we happen to be injecting with FedEx, actually, which now we happen to be injecting with UPS. Instead, we're going to say shipbuilder.buildShip. We will find some logic here to tell it if it's going to be UPS or FedEx for this exact instance. So we will dynamically decide, should it be FedEx or UPS, whatever we happen to pass in here. This will give us that iShip service. So this build ship gives you back the iShip stuff service. and then we can call calculate stuff, and it's all the same from then on. Everything ends up being the same. So we've changed this constructor here, and we saved it. We come over here, and rebuild. Hey, everything looks perfectly fine. There's no problem at all here, is there? And then let's go ahead and say run. And, oh, what? This page isn't working. Why isn't this page working? No. If you know what you're doing and you've seen this before, you can look through the logs and you can figure out, okay, I know what's going on. But one of the things is this programming here happens in a different library. This is a completely different library. And so I should be able to test this and make any changes to this, do some unit tests or whatever the case is to this whole library and push it. And I should be done. Anything else should be flagrantly obvious that I've broken something. However, anyone else working inside of the consumer, this web API, whatever it is, they should feel free at any time that they want to pull in updated versions of NuGet packages. Things should be feature gated. Nothing should break. But when they pull that in, they should see a very clear warning here that, hey, your constructor has changed. Things are broken. It's not going to work. It's just not going to work. But they can't do this because what we've seen here is that this doesn't actually depend on an actual constructor like these do. This is just saying, just find a constructor, and then hopefully you've injected all the right things. Of course, I can just come down here once I figure out what the problem is, and I can say I want to inject, the ship builder, whatever the case is, and run it, and voila, it works. But to a person who's working in this API and they're just updating NuGet packages, which they should always feel free to do because, like I said, feature gating and proper development practices. They've updated the NuGet packages. They build all of the unit tests for whatever's in here might run and work, and then they push to production or they push to the next environment. And of course, once they push that, something that they're not even working on, because maybe they're working on some other part of the system, something else breaks because at build time, at compile time, it didn't tell you any sort of warning. Whereas over here, if I were to say, I don't want to go through all that. But if I were to instead say register DI program artifact DI program register. If I had the same thing here, instead, you can see that if I had done this explicitly, then I would have gotten this error. So anyone who would have come and updated the NuGet packages would have come in here, they would have built, and they would have said, oh, what's wrong? We don't know. This isn't what belongs here. Someone's changed the constructor. It's very explicit. It tells you exactly what's wrong. This isn't mediocre stuff. This is the construction of your application. It's important to be explicit, and so you don't want to do that. I'm going to go ahead and cut it off right there. There's some other no-nos that you can follow, but if instead of knowing all the no-nos, which you should learn from experience after doing the yes-yeses, if you instead just follow the good programming practices of DI, register DI, of doing dependency injection, being explicit, changing your code so that your code doesn't directly depend on the implementation. Your code should depend on abstractions and interfaces. Then your code becomes much cleaner, much easier to read, much easier to test, and easier to swap out dependencies. So that's what dependency injection is. It's one way to achieve inversion of control. And feel free to jump into the code. Feel free to jump into this meet right here, which I believe Kimberly will post a link to in our Slack. And we can chat. You can say, hey, what did you mean by this? What's going on? How do you do this? Well, what if you have this example? Whatever you want to ask me, jump in there and let's talk. And yeah, I hope you found this informative, and we can talk later.